Okay, assalamu alaikum everyone. So this is our next class, lecture 2, and today we will discuss about the microcontrolling, the basic components of the microcontrolling unit. So I have already talked about this Arduino board, and there is a special element, is the heart of the heart of the Arduino board. Okay, so this black chip is the ultimate 80 mega 328P, 8 mega 328. So this 8 mega 328 looks something like this, similar to this. How? If we just take it out from there, drag it out from there, then this chip is basically the same as to the TV. So here's a small cutout over there. This is the 1. This starts from 1, counting from the legs, and this one is starting from the small amount of curve. This light parabolic curve over there. Okay. So how do you get to know about this parabolic curve? Okay. This parabolic curve is something like this. So is it visible over there? Yes. Okay. So this is the pin number 1, 2, 3, 4, 5, 6, 7, 10, 14. Consequently, 15 from the other side to the 28. Okay. So these pins has been generated from 1 to 28, and you have to know this rotation. You can't count the 1, 2 like this because it is officially, academically, and by default is generated from 1 to 28 like this. So this anti-clockwise rotation from here to there. Okay. So you have to find this parabolic shape over there. So this is the 80 mega 328P, and gradually we'll know the operating voltage, input output pins, digital pins, analog pins to the particular board. So before that, this is the ultimate microcontrolling unit, is 80 mega 328P. Okay, and it has some internal memories, some RAM and clock speed over there, because without that you can't generate any codes, you can execute any output, and whenever the sensors are taking the values from the environment, it will come to the Arduino board, but he or she, it won't gonna take any kind of value over there, because you will have to make it functionally well. If you can't functionally well, then it will not execute any operations. So to execute any operations particularly, you have to know details about that pin numbers, how they works, and that's the mother, I say, that's the mother or heart of the Arduino board. Because this Arduino board you are watching right now, so see, there's some digital pins over there, there's analog pins over there, some 5-volt pins, TXRX pin. These are the rename pin. Actually, the nomenclature has been set over there by the engineers, by the authorized, by the Arduino company. But before that, this pins has been made to the market. Okay, this has been found to the market, and with this pin numbers, the board has been generated and make the ports different and distinguished in a different sector, like port A, port B, port C, port D, and that portions are connected with this digital and Arduino pin. Let's make it simple. Like this is our MCU, the black portion, 80 mega 328P. Okay, so it contains lots of pin numbers. So what? Here is a pin that is, let's say, analog pin 6. So this is the pin number which is analog pin 7. Okay, here is another pin that is named as analog pin 8. So is it possible to analog pins over there 7 and the 8 is over there? So it's not possible to execute any task. Whenever you are going to arrange this something, so the circuit will get more complex. You have to put some capacitors over there, ceramic capacitors, some filter, some inductor. So as a result, it will what? It will make more messier. It will just got messier. So when it comes in a random way that the tasks are not organized, so to make it organized, this board has been built. Okay? To make the task organized, this board has been built. So what's the sufficient or the significant role of this board? This board basically what? This board takes that wire with the pin, takes that wire and comes to the 8 in that range. Okay, so they make a section of analog pins where they can generate in its own way. So the wire arrangement has been set by the engineers, by the circuit builders, that has been extracted and that is connected in the internal way and put the all analog pins over there, all the analog sections over there. That makes your task very easier. It's as simple as like the periodic table. To the particular nature of the component, they have been set to the particular columns. The inert gas is in a particular column, the metals are in a particular column, the non-metals in a particular column, as well as the analog pins, the digital pins, and the PWM pins. So there are different types of pin. If you say it is the digital pin, and after that you will get an analog pin, so it is very disturbing for you to work on that. Okay. So to make that more simpler, they make some blocks. So this is the blocks PC6, PD0, 1, 2, 3, 4, then again VCC, then PB6, then PB7, then PD5. So it's quite impossible to work on PB6, PB7 and PD5. So is the basic P block, then it comes to D block. So it's a messy arrangement, but it has been generated by the engineers. So the advanced engineers has make it more simpler. How? They make it something like this. So they will define it port B, port B, port D, port B, port C. So how they have defined it? They have defined it in the easiest way. Let's say, is this visible in camera? Okay, let's say it's been 0 to 13. I mean all the digital pins over there. Okay, so all the digital pins over there is something, it's just to the left side. Okay, digital pin in left side. Where? Port D, port D. So how? This is the 8 mega 328P, and if I take something like that, is all the pin comes to the left side? Yes. No. Yes, it right now it comes to the left side, but before that it was in a messy position because this VCC and ground has come over there. Okay. So same goes for all the pins. So to make it more easier, they have set all the pins over there and internally connected the wire through that board. Okay. So you don't need to worry about the connection. They have been made the connection easier. So you have to know about the sketch. You have to just connect with the sources, with the sensors and the outputs. Then after evaluating the sketch, it will make the operation easier. So the engineers have made it more easier to your life to get some valuable outputs, and you have to play with that. Okay. Let's say here is A0 to S5. So the 6 analog pins. Let's find the 6 analog pins. 6 analog pins, where is the 6 analog pins? 6 analog pins, where you can find? Okay, 6 analog pins. Yeah. Oh no, it is 7. Okay, PB0, PB1, 2, 3, 4, 5, 7. That's not PD0, 1, 2, 3, 4, 5, 6, PB, PB not, PBC not. So most probably the PB is analog pins. Okay. Okay. Just taken to make sure about that. It most probably PB 3 to 8P. It's more probably the PB sections. Okay. The PB section consider the analog pins. Okay, let's say A0 to A5, and these analog pins are is something. Yeah, this is port 5 and port 7. Okay, port 5 and port 7. So they have internally made the connection with their own way. So port 5 and port 7, like here say port 5 and port 7, this is the analog pin to this board. So these pins are very much unsaturated. Okay, so you can find that this is the analog, this is the digital, so it's been unsaturated. You're not in a compact way. So the engineers make the board more compact that the analog pins are connected to the A0 to A5. So this is the analog pins. So that side port 5 and port 7 basically the digital side actually. So the analog pins, and you have come to know more about the PWM pin. I will discuss later on the next class to generate, to play with some different type clock frequencies. You have to know about the PWM pin. Okay. So these are the input output pins, I mean power pin in my language actually, to make it power, to give the power, because this board needs some power. It's not going to work on its own way. Okay, it needs some food, and that food is what? Voltage and current. So it needs some voltage and current according to the board. So 5 volt is the optimum voltage that can be worked on that. Work on this board. So that's how it works. These 8 mega ports are very much critical, and you have to know about that. Oh, let's say, sorry, this is the analog pin. Okay. So how many pins over there? 28 pins. Okay, let's count. So P6, 1, 2, 3, 4, 5 is analog pins of input numbers. So these are the analog pins over there, but in boards, analog pins are over there. So it is generated in its own way. So if you're going to work on that, it will get messier. So these are the ultimate scenario. Analog pins are port C, so you will get 6 pins. Port D are the digital pins, D for digital. So you will get how many pins? 0 to 7. Then what? Then 7, 8 pins, port D. And you have also the digital pins in 0 to 6. These are also in port B. So port B and port D are the combination of digital pins. So 6 and 7 as the ultimate 13 pins over there. So sorry, 6 and 8 are the 14 pins over there. So 14 plus 6 is equal to what? 20 pins over there. We have come to know that there are 28 legs. Is it? 28 legs. 28 pins contain this one. So let's count. Okay. Well, we have found 20 pins, 14 digital pins, and what? 6 analog pins. So 6 analog pins over there. So 14 is over there, 0 to 13. So apart from the 13, there is a, you can see, ground and A reference. Okay, is it visible? Ground and A reference. So there's a ground pin to the digital side and an A reference pin to the digital side. So how many pins have been connected? 2 more to the digital section. Okay. So 20 plus 2 is equal to what? 22. So this section has been covered. How much pin do you need to cover up the legs? More 6 pins. So are you getting my point? So there are more 6 legs has been left over there. So let's find. You can see V in to IO ref. So V in 2 grounds 5 volt. V in 1 2 ground 5 volts. So how many pins over there? 4. Apart from that, you have 3.3 volt and reset pin. So how many pins over there? 6. So almost 28 pins been covered over there to execute the ultimate voltage. And there's an additional IO ref pin. 3. There. Yeah, it's been covered. So if you get this scenario, it is very tough to get. I have been researched so much to find all the stuffs, because this mapping is not easy. You will find this one, but you have to count the ultimate result, that which one is analog and which one is digital. Then after the all summary, you will get the ultimately 28 pins that will match. So ultimately, in a nutshell, these pins has been what? Exhibited, separated, saturated to the ultimate board. So you have to know about details of the board. Okay, the research enthusiast will do what? He'll take the board. Okay, I will just buy the board from the market, and okay, let's start connected. Then you are the engineers. Probably you will solve the result, but you have to know the basic. I'm not telling you that make the board over there in overnight, but you have to know about the basic. Okay, so you'll know about the basic. I think that will be very beneficial for you for your lectures. In further procedure, you will know about more about what is voltage, is current rating, the power consumption rating, and all the other stuffs regarding to this board. So I think that will be more helpful to you. How many times you have left for the class?
50, 40.
Okay, so yep, that's it. And that's the end of the today's class. And let's jump to the lecture, our part 2 actually, and that's the continuing process. Okay. So, okay. As we distinguish the difference between what? Microprocessor and microcontroller. So these are the ultimate parameters or the specification which is relevant to the microcontroller unit or the microcontroller. So you have the UNO board at the specification, the power supply, the input and outputs, the memory and communication, the programming, the pin details, the connecting ports and chip. Whenever you have come to know all this stuff, you are the boss of the microprocessor and interfacing. Okay, so how do you get to be the boss over there? So ultimately, both. Ultimately, these specifications have been very much relevant, number one. Number two, to the power supply. You have to know about the specific power supply because you can give the AC current to that board. This board has been operated with what? DC current. Okay, because the sensors, the result are ultimately the DC. But you can work on the AC adjusting with some relay. Have you heard the term relay? Okay, so there's a AC relay and DC relay, and you can work on that. But that's not prime concern. We have to know that it has worked. That's the basic phenomenon of it to work on the DC current. So DC current means DC voltage. So it needs DC source. The source can be executed from the AC. The source can be generated from the AC. But at the end of the day, at the end of the input of its Arduino board, the main connection is obviously the DC. What is the input and output? Please talk about that. What is input and output? Input means what? What is the input of this Arduino board? So exactly. So when you are connecting the sensor, all the pins are considered as an I/O pin. Do you know the I/O pin? I/O pin means input and output pin. Okay. So this input and output pin depends on what? On your particular task. So the input and output pins basically are very much relevant to the pin details. Okay. So memory and communication. So there is what? There is a ROM, flash RAM, flash, EEPP ROM. Okay. So it has a very 2 kilobyte, 1 kilobyte, 32 kilobyte RAM size for the particular size. Say. So you have the PC. So according to your microprocessor, you can save your file to your hard disk, to your SSD. But over there you can't save your files. But for the particular sketch, you may save one sketch to the EPROM because the size is very much low. Very much congested. Okay, like 2 kilobyte, if I'm not wrong. What is the size of the EPROM? 2 kilobyte, isn't it? 1 kilobyte. So it's very, very. It's not so much prominent, but very much low in size. Okay, then Arduino programming, I have talked about that. Arduino programming itself is a language, Arduino language. It's the updated version of C++. So whenever you have come to know about the C++ or C, you can easily code over there with the Arduino programming. Okay, and pin details, I have talked about the pin details in the last class, the last lecture, where all pins have been saturated. And you have come to know with the three basic pins. One is the analog pins, one is the digital pins, and other is the PWM pin. So analog pins are something like that, is working on the analog values. Like, let's take an example. You are going to turn on the light, or you are going to turn off the light. So how many conditions do you have? One or two? One or two. How many conditions? Two conditions. So two conditions depends on two values, whether it is on or off. So according to your Boolean algebra or according to your basic concept, on means what? We have been learned from ICT, it's 1, and off means what? 0. So digital means you have 1 or 0. So to execute the value of 1 and 0, to turn on the light or turn off the light and turn on the light, you need 1 and 0. So you have to connect the LED or the light or the output To which side? Analog, I mean analog pin or digital pin? Digital pin for what? Because they are generating 1 and 0. Okay, now let's say we are going to change the intensity of light, or if it okay, let's give a pause over there. We are going to drive a car. So is it possible to drive a car like, okay, I'll just start the car, it will just move around and without any speed, without any control? So you have need a particular control, right? Sometimes you get slow drive, you'll have to be more faster, you have to overtaking your front vehicle that is in front of you. Sometimes you need to push the brake over there. So it is generated by you in your own procedure. You have to control this. So whenever you want to control something, so is it possible like controlling with just for two values, 0 or 1? So you need lots of parameters over there, lots of values over there. So to that particular values, then you need 0 to 255 something which is relevant to your maximum speed to minimum speed. So you want to drive your car at maximum speed, so set the value to 255. You have to take down and stop the car, you need 0 to 0. And if you want to set the value to 255, so you are having your ride in a moderate speed. And if you want to make more speed, or you want to put some more speed over there, more than moderation, but I mean more than your moderate speed, then what will be the other value? 200, 180, 220. Are you getting my point? So it's more than your average speed, the moderate speed. Okay, so that's how you can execute a value. I mean you can play with the values. Okay, so the motors can never be run with 0 and 1. Why? Because if you turn on the 1, then it will just start from over there and go boom. That's not the end of the scenario. Okay, picture abhi baki hai. So you have to do what? You have to put the analog values over there. You have to play with the analog values that you can manipulate and generate the values. Okay. Now let's say if you control the intensity of the light, then what are you going to do? Are you going to play with the digital value or analog value? Analog value, because now this light is at high speed. You can say, sir, I just don't want to turn off the light, but I just want to less brighter. I mean, the room will be something like dim. Okay, like something dark, but not so dark. It will be like something like, okay, less light over there, not so much light, because I don't kind of light over there. So whenever, so what you have to do? So you have to change the value, but you have only two values, 0 and 1. Are you going to set the value 0.5? It's not possible. So you have to work with the analog value. That's the role actually have been set to the analog and digital. So there are some special pins. These are called PWM pins, pulse width modulation. These pins are so much efficient whenever we are going to work with the speed and the clock, to the pulse, to the clock speed, relevant to the clock and pulse speed, then you have to work on that. So to work on the driver module speed, you have to connect your module with the PWM pin. So analog pin is good, but especially PWM pin is made for this. Okay, so we'll talk about later. That's the pin diagram, connecting board and chip. To connect this board, whenever I'm just connecting my laptop right now. What? I'm connecting my laptop with what? With an cable to this particular board. And is it something like you get some power overnight, over days, by manually, by wireless is something? You have to put a port over there that has been connected to the AC current. Okay, so by this way, you can say that this laptop will get charged from there, then it will work by its own way. Is there any storage over there? Is there any storage over there that is going to be same work or purpose, the purpose will be the same as the laptop? Obviously no, the workload is different, the power consumption is different. So you have to connect it in different way. Here is the manual port that has been uploading port, printer cable that has been connected with the laptop or PC. There is another black port over there, you can see. This black port is basically what? Is a powered black port where you can connect with the adapter, 9 volt 12 volt adapter. And there are some basic power pins over there, 5 volt, 12 volt, 15, 20 volts. You will know details about the voltage in the next class. Okay. So that's the connecting board and chip. You can operate with a particular voltage. So that's the end of the today's class, and I hope you'll get to know about the details about that. So thank you so much, and I hope you'll enjoy the class. Okay, thank you. Assalamu alaikum.